गुड इवनिंग एवरीवन। आज हम एल्डिहाइड कीटोन एंड कार्बोक्सिलिक एसिड स्टार्ट करने वाले हैं। लेट्स बिगिन। फर्स्ट ऑफ ऑल, एल्डिहाइड्स और कीटोन्स ऐसे फंक्शनल ग्रुप होते हैं जिनमें कार्बोनाइल ग्रुप डेट इज सी डबल बॉन्डो प्रेजेंट होता है। एल्डिहाइड्स में टर्मिनल में प्रेजेंट होता है और कीटोन्स हमेशा इन द मिडल ऑफ द चेन प्रेजेंट होते हैं। दैट इज कीटोन्स ऑलवेज हैव टू बॉन्डेड कार्बन एटम्स। नाउ कार्बोनाइल group has a partial electronegativity difference which is created due to the electronegativity difference of carbon and oxygen respectively, which gives them partial positive and partial negative charges, which would be used further in the reactions which we will see in the upcoming part of the chapter. Now their nomenclature for aldehydes, the nomenclature simply replaces the E of the alkane with Al, such as an aldehyde of a singular carbon is known as methanol. For two carbons, it is known as ethanol. These are the common names for these formaldehyde, which you might have heard is used for storing specimen in different labs, and acetaldehyde is the common name of ethanol. The nomenclature of ketone, the suffix E in alkanes is replaced by one, such as propanone and butanone. Propanone is the simplest member of the ketone family since it requires a minimum of 3 carbon atoms to be denoted as a ketone. These are the common names. Dimethyl ketone or acetone is the most prominent ketone which we use on a day-to-day basis. It is also a key prominent ingredient in nail polish removers. Now their preparation can be done by multiple methods. The most common one which we use is by oxidation of alcohols using different oxidizing agents. Primary alcohols can be oxidized with CrO3, which gives you alcohols, and secondary alcohols when oxidized give you ketones. Secondly, by dehydrogenation of alcohols we can achieve this. Primary alcohols heated with copper at 573 Kelvin give you aldehyde as a result, and secondary alcohols heated with copper 573 gives you ketone. Tertiary alcohols do not give you aldehyde or ketone, they get converted into alkenes. Now secondly, by ozonolysis, which is a very prominent reaction and important for examination point of view. Now see, we take an alkene in ozonolysis. As you see, a double bond here is present. This double bond gets split in between and we get ozone gas and zinc in presence of water. Now this ozone gas has 3 oxygen molecules. One oxygen atom goes with zinc atom to form zinc oxide as a byproduct. The other 2 oxygens are divided equally on both of the sides of the double bond, and therefore you can obtain aldehyde or ketone depending on the configuration of the alkyl groups and branching of the chain. Some examples are given here. You can form benzaldehyde in such a way. If you have a compound present in such a manner, you simply have to divide the oxygen equally on both sides of the double bonded carbons. Thirdly, by hydration of alkynes such as acetylene, which is also known as ethyne, when added water in the presence of mercuric sulfate and H2SO4, it converts into acetaldehyde and an alkyne with an alkyl group attached to it gets converted into ketones in the presence of same reagents. Now those were the methods which can be used for both aldehyde and ketones. Now these methods which we will be discussing above can only be used for aldehydes. First is the Rosenmond reaction, name reaction, therefore important for your board examination. We take benzoyl chloride, COCl group attached on an aromatic ring, and we use Lindlar catalyst H2 palladium barium sulfate to convert it into CHO, benzaldehyde. Formaldehyde cannot be prepared since HCOCl is highly unstable compound. Now secondly, from nitriles, if we take cyanides and reduce them in the presence of SnCl2 and HCl, This mixture yields you hydrogen gas in the presence of dry ether, and then we do hydrolysis. This compound is known as imines, and after hydrolysis of imines we get aldehydes. This is known as Stephen's reaction, another important reaction for your examination point of view. Alternatively, if you have nitriles, you can use diBAL H also, diisobutyl aluminium hydride. This also provides hydrogen atoms for reduction. Similarly, this is a prominent use of diBAL H, specific case asked in the examination. Wherever you have esters RCOOR, therefore you can use diBAL H to convert it into aldehydes. Next, Itard reaction, another important one asked multiple times in examination. You take toluene, you use chromyl chloride CrO2Cl2 in the presence of carbon disulfide. It first forms a chromium complex. Afterwards, when you hydrolyze it in acidic medium, it converts into benzaldehyde. Side chain halogenation followed by hydrolysis. We take toluene, we do halogenation in sunlight presence, therefore it forms CHCl2. Afterwards, we do its hydrolysis, which converts it into benzaldehyde again. Next, Gattermann-Koch synthesis. Benzene reacts with CO and HCl in the presence of Lewis acid. This HCl, the chloride atom, gets attracted towards the Lewis acid since this is electron deficient, and we are left with HCO group, and therefore it goes and attaches to the top of the benzene ring, giving us the final product of benzaldehyde. Now moving on to preparation of ketones. We use acyl chlorides. We use Grignard reagent in the presence of cadmium chloride to form this complex, dimethyl cadmium or dialkyl cadmium, and this, when reacted with acyl chlorides in the presence of dry ether, gives you ketones as a byproduct. Now from nitriles, if you use a nitrile and phenyl magnesium bromide in the presence of dry ether, it goes through a chain of reactions, and after hydrolysis the final product obtained is 1-phenylpropanone, which is an aromatic ketone. And last method is Friedel-Crafts acylation. Benzene ring attacked by RCOCl or aromatic halide in the presence of Lewis acid. Same mechanism follows. This chlorine atom gets attracted towards AlCl3 because this is electron deficient and it needs electrons, therefore it gets attracted here. This gets converted into an electrophile, this entire species, and therefore it gets attached to the aromatic ring and forms ketones. Now here are some physical properties of aldehyde and ketones. Methanol HCHO is a gas at room temperature, and its 40% solution is known as formalin. It is a reducing agent and used in silvering of millers. Ethanol is a volatile liquid. Other aldehyde and ketones are liquid or solid at room temperature. The boiling point of aldehyde and ketones are higher than hydrocarbons and ethers of comparable molecular masses due to high magnitude of dipole-dipole interactions. This is a key point for your assertionism statements, so kindly remember that. Aldehydes and ketones have lower boiling point than those of alcohols of similar molecular masses due to absence of intermolecular hydrogen bonding. So the order follows: alcohols, then aldehydes, then ketones, and then ethers, and then alkanes. The lower members of aldehyde and ketones are miscible, that is soluble with water due to formation of hydrogen bonding. However, the solubility decreases with the increase in length of the alkyl chain. Acetophenone is used as a hypnotic sleep producing drug as a medicine under the name of Hypnone. We will continue with the chemical reactions of aldehydes and ketones in the next video. Thank you very much.